This is the very beginning of my hematology series, and in this particular video I will start with lymph nodes. I will talk about the structure of the lymph node, the function, and some of the clinical correlation of lymph node. So let's get right into it. So imagine this is our lymph node. Now lymph node has many efferents, but it really has one efferent. So imagine that these are the efferent arteries and veins. I'm just combining them together. And this is the efferent from this particular lymph node. Now inside the lymph nodes, we have something called the germinal follicles. So let's call this germinal follicles. Germinal follicles is where B cells proliferate. Now these are not the only structures that's present in a lymph node. There are other structures in between these germinal follicles, okay? And this is called the medullary sinuses, or you can call them the medulla of a lymph node. And in this medullary sinuses, or the medulla, you are going to find macrophages. Now these medullary sinuses communicate with our efferent. So anything that comes into the lymph node has to pass through this medullary sinuses to make its way out into the efferent. And I will tell you in a minute why that is so important. But first let me go over the other structures of the lymph node. So now we are left with the space in between, which is not the germinal follicles, which are nice round follicles over here, not the medulla, but a space in between. These are called the paracortex, and paracortex is where the T cells live. So we can say that the germinal follicles is where the B cells live, the paracortex is where the T cells live, and the medulla is where we have the macrophages, which communicates with our efferent from our lymph node. Now this is the basic premise of a lymph node. Now you can also divide the germinal follicles into even more structures. For example, there is the primary follicles and then the secondary follicles. The primary follicles are more dense, the secondary follicles are going to be pale, and the secondary follicles are the ones which are more active. Now, the germinal follicles also, when they divide B cells, so it is kind of the house of B cells. That's where B cells proliferate. So when B cells proliferate, the end product of all that proliferation, at the very end, we get plasma cells. And those plasma cells, what do? Plasma cells makes antibodies. So this is where I will bring in the clinical correlation that I promised you. Whenever you have an infection, you are going to have increased proliferation of the germinal follicles because the plasma cells has to make more and more antibodies. Now this process of producing more and more B cells and more antibodies is actually called reactive lymphadenopathy. Now just like we had proliferation of the B cells when we needed more B cells and antibodies, and proliferation of the germinal follicles, when we don't have B cells, there is going to be shrinking of the germinal follicles, or you're not going to be able to see the germinal follicles. It will kind of disintegrate, right? If you don't use it, you lose it. When do we have those scenarios? Maybe in Bruton's A gamma globulinemia. So that's an X-linked disease which has low number of B cells and low number of all kinds of immunoglobulins, right? We know that. So that's when you're going to see, if you biopsy a lymph node in a Bruton's A gamma globulinemia, you're going to see that the germinal follicles kind of disintegrate. They are not proliferating anymore. So that is our germinal follicles. Now let's move on to our paracortex. Now the same kind of physiology applies to the paracortex as our germinal follicles. If we have a viral infection, we're going to have proliferation of the paracortex. So we're going to see extreme proliferation of the paracortex when we have cellular immune responses where we need lots of T cells, because let me just remind you that paracortex is the one that houses all the T cells. Now we understand that when we need T cells, we're going to see proliferation of the paracortex. If we do a biopsy, we're going to see that the paracortex is really, really enlarged. But where are we going to see shrinking of the paracortex, or where we're going to see not so much paracortex? Can you think of a disease? It's DiGeorge. Do you remember the disease where there is the third and the fourth pharyngeal pouches fail to develop, and you have tetany, you have no T cells, and if you don't have any T cells, if you don't have the ability to make any T cells, which happens in the paracortex is actually going to shrink, right? So that is our paracortex. Now let's talk about our medullary sinuses. Now the medullary sinuses also contains the macrophages and some plasma cells, and it has its communication to the efferent. You cannot reach the efferent artery or vein if you don't go through the medullary sinuses, and that's because, let's say there is a bug floating in the blood vessels, and the blood brings that particular microbe onto the lymph node, and it has to go through the macrophages, or it has to bypass the macrophages to make its way out through the efferent, and that's where the macrophages does its job. It's going to take it up and try to kill it. So that's why medullary sinuses is very important in a lymph node, because this is like the police force where they're waiting and kind of checking everyone that's passing through, and its job is to kind of monitor what is coming into the lymph node and what is going out. It's kind of like quality control of what's going on in the blood that is coming into the lymph node. Now let's make it a little more interesting. So if I say disease such as histiocytosis X, which part of the lymph node are you going to see proliferation when we're talking about histiocytosis X? Now, what exactly is histiocytes? Histiocytes are Langerhans cells. They are kind of the derivative of the macrophages, right? Where do we really see macrophages? Well, like I mentioned, we see macrophage in our medullary sinuses. So we're going to see proliferation of our medullary sinus. That was a tricky one, right? Now let's make it a little bit more interesting. What about SCID, where you have low B and T cells? Now what exactly is SCID? SCID is or severe combined immunodeficiency disease. That's when we have lack of B and T cells. So when you have lack of B and T cells, which cells are really going to proliferate? Because you don't have B cells, you don't have T cells. So what will compensate that whole process? Histiocytes. Now histiocytes, where can we find histiocytes? In the medullary sinuses. So you're going to see not much of germinal follicles or paracortex. You're going to see just medullary sinuses in SCID. Now that is a basic premise of a lymph node. Some other things I'd like to mention here is when you have tender and non-tender lymphadenopathy. If it is tender, chances are it's not malignant. It's probably a localized infection 99% of the time. If it is non-tender, that's when you have to worry about whether this is going to be malignant. Chances are that 99% of the time, a non-tender lymph node proliferation is probably a metastasis, which is the number one cause, or it's a primary tumor of a lymph node. Okay, so that is the difference between painful and non-painful lymph node proliferation. But what about another way of looking at it? What about generalized lymphadenopathy and localized lymphadenopathy? If you have generalized lymphadenopathy, you should be worrying about things like, maybe a viral infections, which is going to cause all the lymph nodes to proliferate. But if you have localized lymphadenopathy, then you're thinking something more specific to that lymph nodes. Maybe it's a draining sinus. Maybe again it can be infection, or it can be malignancy. All that you can take into account in a localized lymphadenopathy.